Okay, so somebody sent me a question about a combustion homework problem. So I'm going to make a little video for everybody. So combustion, and this is in your notes, right? Combustion is basically the burning of hydrocarbons. And so you can have two different forms of combustion. You can have complete or incomplete combustion. And both actually kind of happen like in the engine of your car. You know, you put gasoline in your car, and gasoline is an example of a hydrocarbon. Oops. So here's an example of a hydrocarbon. So you take that hydrocarbon and you burn it in the presence of oxygen. So all combustion reactions must include oxygen as a reactant. And it will form, if it's a complete combustion, carbon dioxide and water, and then heat energy, right? And that's what we use to drive our cars. And you can have complete, or you could have incomplete combustion, where you take that same hydrocarbon, burn it in the presence of oxygen, and you get out carbon monoxide and water. But if you don't see it being listed as incomplete, you can automatically assume that it is complete combustion. So if you look at our homework problem, it says upon combustion, a mole. So remember, in a balanced chemical formula, a mole, or the number of moles of a substance, is indicated by the coefficients, the big number in front of the formula. A mole of a hydrocarbon, they don't give us the formula of the hydrocarbon. So if this is combustion, by definition, there must be some amount of oxygen present. Now, they don't tell us how much, they don't tell us how many moles, so that's something we'll have to fill in. And it produces 8 moles of CO2 and 8 moles of H2O. So I know that this is CO2, so it is complete combustion. Let's see. And now determine the molecular formula of the hydrocarbon. So in order to do that, it's just balancing a chemical equation. We know in the products, we must have the same number of atoms as we do in the reactants. So if I look on the product side, carbon, I have 8 CO2 molecules, and for every CO2 molecule, it contains 1 carbon atom. So 8 times 1 is 8. And then a hydrocarbon is carbon and hydrogen. So if we look at hydrogen, over here we have 8 molecules of water, and in each molecule of water I have 2 atoms of hydrogen. So 8 times 2 is 16. So I know that my formula for my hydrocarbon is C8H16, because that gives me 8 times 1, right, is 8, and then hydrogen is 16 times 1, right, 16. So we know that's balanced. Now, we have to worry about balancing the chemical equation completely, so we're worried about what's the coefficient here in front of the O2. So we got to go in our products and look at oxygen. So for oxygen, we have in carbon dioxide, right, 8 molecules of carbon dioxide, and for every 8 molecules, right, well, in every molecule of CO2, you have 2 atoms of oxygen. So that is another 16 of oxygen, but you also have oxygen here in water. So you have 8 molecules of water, and for every molecule of water, you have 1 atom of oxygen, so that's 8. So the total for oxygen is really 16 plus 8, and that is 24. So over here, our oxygen must equal to, whatever math we do, must equal to 24. So I know that I'm going to use a molecular oxygen, so it's going to have 2 oxygen atoms per molecule. So I can put the 2 there, and then what times 2 is 24? That's 12. So there's your filled in things, right? Now you have to write the whole chemical equation. So when you write it, you just don't write the one, it's understood. C8H16 plus 12O2 yields 8CO2 plus 8H2O. And that's it. That's what I wanted to do.